Hey guys, so I want to get into the second part of 17.2 and let's talk about these forces of genetic change. So let's get moving. So there are going to be 4 different forces of genetic change that we're going to talk about. These are going to be forces that are going to act against genetic equilibrium, right? So if you remember, equilibrium is like we want to keep things consistent, pretty much the same or as much as we can, or let's just say minimize the amount of genetic change, okay? But these are forces that are definitely going to try and disrupt the balance of this equilibrium. So the first one is going to be gene flow. That is going to occur when genes are added or removed from a population, can be caused by migration. 2 is going to be non-random mating. This is going to happen when sexual reproduction creates some sort of possibility that mating patterns or behaviors can change, and that is going to influence the gene pool. 3rd is going to be genetic drift. These are going to be random events of everyday life that can cause a loss of alleles in a population. You actually saw that in your 16.3 notes. So if you're a little bit confused, just flip back, pause the video, and take a look back at that. And then the last is going to be natural selection. So natural selection is definitely going to eliminate individuals with certain traits from the population if they're not traits that are going to be helpful for them for survival. When we talk about population size and evolution, allele frequencies are more likely to remain stable in a larger population than a smaller population. So that is going to mean that this force of genetic drift, these 4 things that we've been talking about, are always going to be stronger in a smaller population than in a larger population. All populations are going to have a certain degree of genetic variation. Individuals tend to produce more offspring than the environment can support. If you remember back when we were talking about the ecology unit, right, we talked about limiting factors and carrying capacities, right? There is a certain amount of individuals that the particular environment can support, and if we even try and stray above that, then we're going to have mass consequences to get us back down to that carrying capacity. All populations are going to depend on the reproduction of individuals. In your book, it uses this quote that evolutionary fitness is going to be measured in grandchildren. So that's how you measure how successful you are, is basically how many children that you have. All right, let's get into the particular patterns of natural selection. So there are going to be 3 major patterns that we're going to talk about, and these are going to be patterns that are going to affect that are possible in the way that natural selection affects the distribution of traits. So when we talk about this, we're going to be talking about the level of the different traits over different periods of time, depending on what's going on in the environment. So the first one we're going to talk about is going to be directional selection. And basically what I want you to realize is that the peak of normal distribution is going to move in one particular direction away from the other. So in this case, selection is going to act to eliminate one extreme from a range of phenotypes. So the example that I'm going to give you is going to be anteaters. So if you take a look in the very beginning, we had anteaters that had short tongues, and then as time went over, the tongue length progressed and got longer, okay? And that's because anteaters with longer tongues can get more food than anteaters that have smaller tongues. So over time, the population tended to lean toward the anteaters with the long tongues because they were able to get more food, and they were the ones that were able to survive. They were the ones that were able to reproduce, okay? So that is going to be directional selection. When we talk about stabilizing selection, basically this bell curve shape is going to become narrower. In this case, selection is going to eliminate individuals that have alleles for any of the extreme types. So the example that your book gives is going to be lizards. So after a lot of generations, or many generations, there were fewer very large lizards and fewer very small lizards, okay? So this is just showing you that the degree of variability has decreased and the population becomes more uniform. Okay, so on the left side, we have the small lizard. On the right side, we have the large lizard. What ended up happening, basically because it was more favorable for the lizard in the environment that it was in, the moderate lizard is the one who survived. So in the population, the degree of variability, meaning the amount of small and large and medium, the degree between all of them in the population has decreased, and now there are more of the medium-sized lizards than there are the large or the small. The last one is going to be disruptive selection. And here's the deal. The bell curve is going to be pushed apart in two peaks. So what that means is that selection is going to act to eliminate individuals with average phenotype values. Okay? Meaning that the animal that had the extreme phenotypes are going to survive the best. The one that your book talks about is going to be light color oyster shells. So the color of the shell was dependent on whether they would survive or not. And that is because the light color oysters would blend into the rocks and the shallows, and the darkest would blend better into the shadows. Okay? So now we have the light color oyster who's like, yo, I can blend into the rocks. And then you have the darkest oysters that are like, yo, I can hide and blend into the shadows. This oyster color shell that was in the middle, which we're calling the intermediary range, would show up whether we were in the shallows in the light color area or in the darkest color area, making them easier prey, meaning that their numbers are going to decrease while the light color oysters and the dark color oysters are going to be maintained in the population. Okay? The last part of this section is going to be speciation, and this is going to be chapter 17.3. If you would like some page references, that is going to be page 411 to 414 in your book. So let's get into it. All right, in terms of forming new species, you're going to recall that a species is going to be a group of natural populations that can interbreed, meaning that they can have offspring with each other. Speciation is going to be the process of forming new species through the evolution of the species that are already there. So those are the pre-existing species. Obviously, like almost everything else, speciation is going to occur over many generations. All right, so let's talk about some definitions. So let's talk about reproductive isolation. So speciation is going to occur when evolutionary forces result in a population that has unique features and it is reproductively isolated. Okay, so when we talk about the actual definition for reproductive isolation, it is going to be a state where there are two populations, but they can no longer breed to produce future offspring. Okay, so basically what's going to happen is these two groups that were combining to form offspring are now going to diverge or go their own separate ways, and they may be subject to different forces, meaning that the factors that are going to affect them are going to change, so they're going to diverge over time. Different mechanisms of isolation. So divergence and speciation can happen in many different ways. All of these may contribute to reproductive isolation of populations. The first one is going to be geographic isolation. There is going to be some sort of physical barrier that is going to prevent the species from breeding. Okay, and then that means that obviously there are going to be some differences in the populations based on this geographic isolation. The next one is going to be behavioral isolation. So this is going to be caused by a difference in mating behaviors. The third is going to be temporal isolation. So basically, when we talk about temporal, it has to do with time. So this is going to exist when timing prevents reproduction between populations. Okay, that is the end of your 17.3 notes. You guys are going to have some activities that are going to put all of these factors into, I guess, on your radar. So hopefully this was helpful just to give you a background so that when we do the activities, you'll have the knowledge that is necessary. Okay, if you have any questions, you know where to find me. Bye.